All right, I'm into the last video. So we're here. We're gonna go back now to the page that we skipped right here where it says derivatives of inverse trig functions. Okay, so this is the other part of inverse functions that we're gonna learn today. So we're gonna learn a bunch of different formulas, but I'm gonna show you how you can find them. So let's say that you forget, okay? I'm going to show you how you can find them, so that way if you don't have them memorized, you should memorize them, but if for some reason you forget them, how to memorize them, you'll be able to find them if you can remember these steps. Okay. All right, so let's see. We're starting off with finding the derivative of sine inverse of x. So two things. First of all, actually one thing. As a reminder, when it says sine with the little -1 of x, that is the same as arc sine. Okay, so you'll see it written both ways. Either it's the derivative of arc sine or it's a derivative of sine inverse. Okay, either way, the same thing. All right, let's think about what this means though. So using our same method that we've been using, right? What are we actually trying to think about? Well, sine inverse of x. What does that mean? Well, that means that we're actually looking for when is the sine of theta equal to x over 1. All right, so that's how we get this little triangle over here. If this is our angle theta, right, sine is, opposite over hypotenuse, is x over 1. And we get this third side by doing Pythagorean theorem, right? It's the, a squared plus b squared equals c squared, okay? So, that's kind of nice for us, right? We get this little triangle with all the different sides. Okay, what we're going to do now is take the derivative. So we're finding the derivative of sine inverse of x. Now, to do this, we're going to actually be taking the derivative over here, okay? So what is the derivative of sine? Well, we know it's cosine, and what we're thinking about is that we're actually taking the derivative of cosine theta, which is not x. So therefore, we have to add on a d theta dx. This is an example of what kind of differentiation? Implicit differentiation, where you're taking, we were doing dy dx, but in this example, we're doing d theta dx. Our theta is functioning as a y, right, as another variable. And then that's equal to 1, which is the derivative of x, okay? So then we're solving for d theta dx, which would just be, we're dividing by cosine theta, which is 1 over cosine theta. What is cosine theta? If we go over here, cosine is adjacent over hypotenuse. So this is our adjacent over hypotenuse over 1. So therefore, 1 over square root of 1 minus x squared. That's your formula for the derivative of arc sine or derivative of sine inverse of x. Okay? All right, you just found your first trig inverse formula. Awesome job for the derivative. All right, next page. Oh, that's not what I wanted. Next page. There we go. All right, so now we're looking at arc cosine or cosine inverse, right? That means that we're looking for when is cosine theta equal to x over 1. So here, it's a new triangle, x over 1, and then the square root on that side of the triangle. Okay, let's take the derivative. Derivative of cosine is negative sine of theta, d theta dx, because it's implicit differentiation. Derivative of x is 1. We're solving for d theta dx, so we divide by negative sine theta on both sides. And what is negative sine theta? Well, it'd be negative square root of 1 minus x squared over 1. So negative 1 over square root of 1 minus x squared. Great. And one more that I'm going to show you how to do, and that's tan inverse or inverse tangent. So what are we looking for? Well, we're looking for when is tangent of theta equal to x. Let's take the derivative. What is the derivative of tangent of theta? You should have this memorized. It's also, you gotta have it memorized. Secant squared. So secant squared of theta, d theta dx, that's equal to the derivative of x, which is 1. We're solving for d theta dx. 1 over secant squared theta. Well, what is secant squared? That's 1 over cosine, or the opposite of cosine. So therefore, that's really, secant squared would really be hypotenuse over adjacent. So it's 1 over square root of 1 plus x squared, right, all over 1. And that whole thing squared because it's secant squared. So what is that? That would just be 1 over 1 plus x squared. So you just found your third inverse trig function. Kind of cool, right? You were able to find those. So here are all 6 of the inverse trig functions that you need to memorize. Memorize, memorize, memorize. Okay, oops, memorize. All right, I want you to look for patterns in these, okay? So you'll see here, we start off with the two easiest functions, the ones we're most used to using, sine and cosine. Look at what's similar to them. They're both over the square root of 1 minus the u squared or x squared, right? The difference is that cosine is negative, and that is okay because think about the maybe that matches with our how cosecant and cotangent are negative, right? Cosine is another C word, and it's negative. Kind of nice, right? Tangent is different, but tangent is similar to cotangent in that they're both divided by 1 plus u squared. Cotangent, a C, that's negative though, okay? And then we move, so I like to think about combining these two and looking at the patterns, then looking at these two in the patterns, and then finally looking at cosecant and secant and what are the patterns here. Cosecant and secant, those are the ones we're least used to using, and those are the ones with the weirdest denominator, I think, right? We divide by the absolute value of whatever's on the inside of the sign of the trig function, and then times the square root of the inside squared minus 1. Okay. Now what you'll see is that all of these are written with u's. Okay. Now think back to last class when I introduced that u notation. U can be anything. Again, you can be anything, right? But use the inside. That got me all messed up because I was thinking about the joke from last class, Anyway, you can be anything. That's in the inside of your trig function, right? So it could be 2x, it could be x squared, it could be 2x squared plus 7, right? Whatever that is, that whole thing is going to replace u. And then it would be chain rule, right? So that's why all of these have a u prime on top of them, because it's chain rule. You have to multiply by the derivative of the inside. Let's do some practice. Okay? All right, so first we're starting with sine inverse sine. So we look up here, inverse sine is where we're taking 1 over the square root of 1 minus the inside squared. So I like to start it off by just doing the first part, right, with the 1 over the square root of 1 minus the inside squared, and then I multiply by the derivative of the inside, right? If you want to combine them and just do it in one step, totally fine with me as well. But I like to show, I'm taking first just doing 1 over whatever the square root is or whatever the denominator is, then I multiply by the derivative of the inside. Up to you how you choose to do it. All right, B, so now we're looking at tan inverse. So inverse tan, so that's where we're dividing by 1 plus the inside squared. So that would be 1 over 1 plus the square root of 2x plus 1 squared. So that's square root squared. And we have to multiply by the derivative of the inside. What is the derivative of square root of 2x plus 1? Pause the video and try to find that right now. Try to write it down. And hopefully you got 1/2 times 2x plus 1 to the negative 1/2. And then we got to multiply it by the derivative of the inside again. So this is an example of chain rule. All right. We got to simplify though. When we square root, that goes away, right? And just becomes 1 plus 2x plus 1. And then we're multiplying that by here. I just went ahead and 2 times 1/2 is 1. And then we move this to the denominator since it's negative. And then lastly, simplify out. You don't need to multiply the whole thing out. Oh, you can't even see that because my face is in the way. There you go. All right. Oh, I can move this. That's fun. All right. Moving on. Okay. Got a lot of practice problems here. All right, so let's look at our cosine of x squared. So cosine squared would be, well, we know it's negative, right, because it's a c, and it's the same thing as sine. So it's the square root of 1 minus u squared, and then we multiply that by u prime, by the derivative of the inside. All right, so first step, negative 1 over 1 minus the whole inside, x squared being squared. We multiply that by the derivative of x squared, which is 2x, and then simplify. The x squared raised to the second power. Our exponent rules tell us when we raise an exponent to another exponent, we multiply the exponent, so therefore it's x to the 4th. All right, here we have another sine one. So this is going to be the same as over here cosine, except that this negative is going to be positive. So try try it on your own. I bet you can do this since we've done a couple sign. Pause the video, inverse signs. Pause the video here and try to solve this one. All right, so hopefully this is how you set it up and you got your final answer. And you don't need to simplify that out in our square root. Okay. All right, let's look at E, inverse tangent of cosine x. Holy cow. If you need to flip back and look at what inverse tangent is, you can do that now, but try to think about the patterns. What could it be? Well, we started off with square roots. Tangent and cotangent are in the middle, right? They don't have a square root, and they're also plus. So it's really 1 over 1 plus u squared times u prime. I think I got that right. Oh, whew, that would have been embarrassing, right? 1 plus cosine squared x, because cosine x, that's our u, that's our inside, and then we have to multiply by the derivative of the inside function, which is negative sine x. There we go. All right, we got another sine one here. You guys can do this. You've had plenty of practice with sine. And look at your inside function, e to the x. Try to remember what the derivative of e to the x is from the previous lesson. So pause the video, try to do this one real quick. It is, whoa, smartboard's kind of wonky. This is 1. All right, so sine, you should have it mastered by now, right? Because we just did 4 examples that had inverse sine. Square root of 1 minus the inside squared, and then multiplied by the derivative of the inside. All right, and when we e to the x squared just becomes e to the 2x multiplied. All right, I think this might be the last problem, you guys. You've made it through this entire lesson. One more problem. You can do this. All right, find an equation of the tangent line to the graph of the function y is equal to arctangent of x over 2 at the point 2 pi over 4. Okay, so basically what we're doing is we're taking the derivative of this function here. So what is the derivative of arctan? Well, I think I just wrote that right here, right? So we're doing 1 over 1 plus the inside squared times the derivative of the inside, which is the derivative of x over 2 is 1/2. And let's simplify that. Well, actually, don't simplify it. Don't simplify it, okay? So we found the derivative. Don't simplify it. All we have to do now is we're evaluating the derivative at 2, right? Because we're looking for the equation of the tangent line to the graph at a specific point. We need to evaluate the derivative at that point to get the slope. So we plug in 2 for x, and we get 1 over plus 1 plus, this whole thing, multiplied by 1/2. That's going to be 1/2 times 1/2, and that's 1/4. Great, we have our slope, and then what else do we need? We need our point, and woohoo, it's given to us, 2 pi over 4. So we plug that into y minus y1 equals m times x minus x1, and we get y minus pi over 4 is equal to 1/4 times x minus 2. There we go. All right, so that's it that I have for videos for you guys today, I believe. Oh gosh, I should double check. Yeah. So go ahead and fill out the Google form where you'll put in any questions that you have for me that I can go over in class together with you guys. And then do the Albert questions as well, just so that you can get some extra practice and so that I can see if you've understood the lesson or not. You can also, when you're done with all of that, get started on your homework or work on homework for other classes. It's up to you. Thanks for watching.